let's start with the topic of today. Today we have only one topic, so we'll talk about SpaceX. Welcome back on the SpaceInfo Club. Thanks for listening if you're listening us on the Spotify and all the major listening audio streaming platform, or thanks for watching if you're looking at us at the SpaceInfo Club channel on YouTube. So we talk about the fact that recently, I would say the other day, they just reached the not the finish line, but the intermediate line, I would say like that, of 300 launches of the Falcon 9 rocket. So we are here on the homepage of SpaceX.com. You have seen, I've seen personally this a lot of time with the spectacular images with a lot of specialized photographers. But I will click on the Falcon 9 page because that's the topic of today. And with the 300 launch the other day, they are on the path of the Soyuz rocket. Well, they are missing a lot of numbers, a lot of launches to reach the 1,700 and more launches with that kind of rocket. Basically not the same one, but if you are wondering, not the very same, physically the same Falcon 9 rocket for sure. That was impossible to make 300 launches with the very same physical rocket. But if you have some numbers, well, in less than 10 years, SpaceX has recovered more than 80, actually something like 85% of Falcon rockets, and more than 90% of the missions, of the current missions, are using reused boosters. So reused Falcon rockets. I'm talking about Falcon 9 rockets, and this fact was allowed SpaceX basically to preserve more than 2,700 Merlin engines, actually avoiding the waste of 15,000 tons of material. And this is huge. This is all avoided waste. This is the frontier. Not that is no more the frontier. This is the future, which is here now, and this is amazing. Actually, they have reused so much times the Falcon rocket. Now you can see on their website that they achieved 327 total launches with the Falcon rocket. I'm not specifying which Falcon because I will be talking about different rockets and their milestones in a moment. They achieved 284 total landings and 258 total reflights. This is an amazing number if you are thinking about that they have lost so few rockets while testing, while trying, while being conservative, adopting a conservative approach, maybe because you are flying a precious payload, maybe the military, for example, have stringent requirements, so the reuse ratio is not 100%, but most of it is for sure due to testing, and but the numbers are going to be amazing. They have reused so much time the very same rocket that a lot of I would say material, but most of it is fuel and engines, which are very expensive. The fuel is also pollution, so all that avoided waste is amazing. And the fact that we have heard Elon Musk talking about reusing rocket like we reuse airplanes nowadays, this is the demonstration that they are very committed to this target. And just to give you some numbers about the Falcon 9 rocket, you can also see it in this animation on their website if you're looking on our YouTube channel. So before going on, I just remember to you to subscribe. Please activate the notification bell. This really helps the channel to grow. Our effort to bring this information, this knowledge of our experts and our engineer to the people. We are very committed to this. We are putting in so much effort. So it's free to just subscribe and share if you can. Thanks a lot. Thank you so much. Also, thank you if you are listening on Spotify or the other streaming platform. Please leave a review or just share the episode with your friends. Thanks a lot. So, numbers of the Falcon 9 rocket. We have an height of 70 meters, 230 feet, a diameter of almost 4 meters, a mass of some more than 500,000 kilograms, and payload to LEO is more than 22 tons. This is a huge payload, and you can also see if you have read our material, we have also started the course of orbital mechanics. You can see how much the mass diminishes if you are committed to reach higher orbits. LEO is almost 23 tons and decreases almost by 3/4 up to 8 tons for just GT orbit. And then if you're are willing to go to Mars, you can only bring there 4 tons, which is actually a lot if you're thinking about this. And this is the Merlin engine. I just a few words on this before leaving the website and just talking about the main milestone of which brought SpaceX up to this point. Just let me know in the comments or in the review what you think. If you want more content about SpaceX, if you have some specific topic that you want us to talk about, let's talk about the Merlin engines. You can see that you can select sea level or vacuum because they can be optimized actually to work at different altitude. Basically, you don't have this optimization, for example, again, for airplanes, for jet airplanes, because the altitude range is quite limited, relatively speaking. So what's the difference between these two engines? Actually, if you're looking at the core of the engine, combustion chamber, turbo pumps, and all that things, you can see that they are basically very similar, even if something like 100% the same. They use the very same propellant combination, so they are liquid propellant engine. They use a combination of liquid oxygen and rocket propellant one. Yes, RP1 stays for that. They have the very same combination of propellant. They are bipropellant liquid rocket engines. But what's the difference? Well, the difference is the nozzle. They have very different expansion ratio. So if you're on YouTube, look for the video where Elon Musk talk about the factory where they build these amazing engines. He will talk about different expansion ratio, because this is the crucial point, the main difference between engines optimized for different altitudes. So if you are flying at sea level, you use the same propellant, but your nozzle is much shorter. But the length is not the first parameter you optimize. This is just a consequence. The first parameter you are optimizing is the area, the cross-sectional area at the exit, so at the end of this nozzle, I would say bell. That's not a bell shape, but very similar. And because you have something like to guide the gas outside the combustion chamber through the throat of the engine up to expanding and then being released to the atmosphere. So if you have, I would say, a relatively high pressure, which is 1 atmosphere at sea level, you just need a small expansion of the gases up to the point they are almost equal to their pressure is almost equal to the atmospheric pressure. Actually, they are usually optimized, in generally speaking, for that said max Q point. So if you have seen the streaming of a live launch, rocket launch, you can hear that at some point they say max Q. Max Q is the point in terms of height from the surface where you have the maximum dynamic pressure, because the density of air decreases with height and the speed actually increases because the rocket is accelerating. At some point you have the I would say relatively maximum velocity of the rocket with the relatively maximum density of air. and at that point you have the maximum dynamic pressure, so the maximum resistance of the air towards the rocket. So you need the maximum thrust at that point. So at that 8 level, at that 8, you just keep that density of the air, and you calculate how much your rocket nozzle has to be expanded. So if we look at the vacuum rocket engine, we see that the nozzle is much bigger. We have different values of thrust, even though they are quite similar. You can see that you have 845 kilonewtons and then 981 kilonewtons. You have some differences due to different optimization, but they are quite similar. But what's the difference? Well, physically the difference, as said, is the expansion nozzle. You can see that it's much bigger. The cross-sectional area at the exit of this nozzle is very big. Actually, if you have the chance to see it live, but to touch it with your hands, you will see how big it is. So that's for the same reason as before, because you are in space, basically you are in vacuum environment, so pressure is almost basically zero. So you need to expand a lot that gases coming out from the rocket engine, and then you have that result that your engine is optimized for that 8, actually for the almost the absolute vacuum. So you have the best results in terms of thrust. So now I've told you some things about rocket engines, particularly about Falcon 9. If you're curious, just let me know in the comments. Contact the SpaceInfo Club on the website or Instagram page, and just let us know. There is also an introduction to rocketry course available on our website, and you can just sign up for it and just get more and more information, or just let us know what you'd like to know. So I will just come back on the home page. I'm just briefly showing our website. This is the home page. This is our mission, what we aim to do, what we did with the companies. We are still doing it with different companies. These are our products, the magazine, the articles, they are all completely free. I strongly suggest you to subscribe to our newsletter and also join the SpaceInfo Club. It is 100% free. Just your email is needed. You can find a lot of articles, a lot of interviews. Again, 100% free. We have some partners. This is our website. I'm just letting you know that if you click on the join button, you can just sign up. Again, 100% free. Last article I'm just showing you is the collaboration we did some days ago with an amazing company. I'm talking about Argotech. It is an Italian space company. They are building, it is also based in the US. We talked about Emilio Fazzoletto, who is an engineer, an electronic engineer working there. They are building satellites. They are building basically the future. They were part of missions, telecommunication mission on our Earth. Also, they are planning to get to an asteroid in the future. They have just released some spacecraft which has reached beyond the Earth's atmosphere. They are planning to go to the moon with their satellites. I strongly invite you to listen to the interview. You can find it on our YouTube channel or also on Spotify. Just look for it. There is a link clearly on our website, so that's super easy. So again, let's come back to SpaceX with the last topics of today. Again, I'd like to talk about the milestones, because today you can see now the Starship. We'll talk about this later in a different episode, so just let me know if you would like to know about this. Now I would like to walk through the path that brought SpaceX to the point where it is now. Well, actually it was founded in 2002, and again, Elon Musk was there. He is one of the founders. I'd like to mention just from now Tom Muller, who is I would say one of the basically fundamental founders of the company, and whose contribution was basically of paramount importance, maybe even more than the contribution of Elon Musk. the knowledge, the technical knowledge, the know-how, and the experience of Thomas Muller were crucial in building SpaceX and putting it where it is today. So basically, I would like to start with the Falcon 9 maiden flight in 2006. It was SpaceX's first rocket, and it soared into the sky on March 24, 2006. Marking the company's inaugural attempt at reaching orbit. Basically, while this particular launch ended in failure, it laid the groundwork for subsequent successes by providing invaluable lessons in rocket design and engineering. So it just paved the way for the know-how of the whole company. Also, Falcon 9's first successful flight was in 2010, so 4 years later, on June the 4th, 2010, SpaceX achieved an historic milestone with the successful launch of the Falcon 9 rocket. Notably, this mission included the first privately developed spacecraft, the Dragon capsule, to orbit the Earth and return safely. So it marked a turning point in the space exploration, demonstrating that private companies could play a significant role in spaceflight. This was only the second milestone I'd like to mention today. Between the first and the second one, there have been a lot of failures, a lot of critical points. So just let me know if you'd like to know to talk more about this. The first milestone is the Dragon berthing with the ISS in 2012. Basically, SpaceX made history again in 2012, particularly May the 25th, when the Dragon spacecraft became the first privately built spacecraft to rendezvous and then dock with the International Space Station. The achievement solidified SpaceX's position as a reliable partner to NASA and other space agencies in resupplying the ISS, and also paved the way for future crewed missions. And Falcon 9 first stage landing in 2015, is one of the most spectacular milestones you will remember for sure. Perhaps one of the SpaceX most iconic moments occurred in December 21st in 2015, when the first stage of the Falcon 9 rocket, the boosters actually, successfully landed vertically on solid ground at Cape Canaveral Air Force Station, landing zone 1, for the most nerds and geeks. This historic landing demonstrated the feasibility of reusable rocket technology, a breakthrough that basically promised a significant reduce the cost of space access. I was talking about this at the beginning of the episode. The fifth milestone is the Crew Dragon's Demo 2 mission in 2020, on May the 3rd particularly, and where SpaceX achieved another monumental milestone with the launch of the Crew Dragon spacecraft atop again of a Falcon 9 rocket. The mission, known as Demo 2, marked the first crew launch for the US soil, since the Space Shuttle retirement in 2011, so something like almost 10 years before, and the first ever crewed flight operated by a commercial entity. With astronaut Bob Behnken and Doug Hurley aboard, Crew Dragon successfully docked again with the ISS, signaling the dawn of a new era of human spaceflight. This iconic moment is one of the most famous in the latest years, and now I just changed the topic, and yes, I'm talking about what you are seeing here in video. I'm going to talk about Starship. Indeed, another milestone is the Starship's first attempted altitude flight in 2020, where SpaceX's ambitious Starship program took a significant step forward in 2020, particularly in December the 9th, with the successful high-altitude flight test of the Starship prototype SN8. The landing didn't went very well, but as we have seen more and more times, I'm just leaving here the details of the spacecraft. I will talk about this in a dedicated episode. The landing of the Starship wasn't a target, wasn't a goal in that test flight, and we have seen that usually SpaceX is over-delivering when executing flight tests, but they don't care that much if things go bad. Usually they are capable, particularly in the last year, of making things go good, where the things have to to go good, so to go well, sorry. So if you have something to test out and that has to be successful, they are usually capable of making that successful, but they don't really care if other things go bad, if they are not the topic of that test flight. They use that data to learn more. Usually they over deliver the result, so basically if they have to test something, they are usually capable of pushing the envelope, but that's not usually a problem if things go bad where things weren't designed to be tested that day, for example. So I would also like to mention the Inspiration 4 mission, because that's not really a technically complicated milestone for the company, but that was a success in terms of public involvement, letting people know what they do and letting them be passionate about what SpaceX is achieving, and basically I would say revive the enthusiasm, something like it was the 60s again. Because in September 2021 SpaceX conducted the world's first all-civilian orbital mission, known again as Inspiration 4. It was led by the billionaire Jared Isaacman, and the mission aimed to raise the funds for the St. Jude Children's Research Hospital and inspire people worldwide. They've been successful for sure in this. The historic flight showcased the SpaceX capability to open access to space for private individuals, and also making a significant milestone in commercial space travel. And the last, I would say, last milestone nowadays, at least so far for the company, is the successful Starship orbital launch in 2022, and the last Starship launch in 2024, because they actually reached the orbital velocity. I would say that the flight can be said orbital only in this term. You can launch a rocket and making it reach something like 26,000 kilometers per hour. This is the velocity, almost the velocity of the International Space Station. It's soaring Earth at 28,000 kilometers per hour. So if that's the velocity for a little lower orbit, but actually the rocket and Starship wasn't inserted into orbit actually by fact, because then it just went down again on the surface of Earth before completing a full orbit, even though it had the speed to do it, probably, we still don't know it. But it was, I would say, again, a success also in this case, because they demonstrated their capability of launching a rocket from the surface of the planet up to an 8 with the required velocity. They had some problem on the control side, and this was the bad thing, because then also the spacecraft went almost lost in the Pacific Ocean. But this was the last deed of the company, and also the last topic of today's episode. I leave you with this. I just thank you for listening, for watching this video. Just let me know in the comments or in the reviews if you're listening on Spotify. Share the video or the podcast episode with your friends, and let me know what you like to hear or to watch the next time. What's the topic that you like more? Thank you for listening or for watching. See you in the next time.